basically, I was 2 years senior in university with students. So, and we have a long association for a number of years. So he will talk today on the enterprise storage nowadays era. So he graduated from the University of Morocco and later he went on to US and his PhD to science at Texas A&M, and after that he has been specialization in storage area. So he has basically now he's a senior manager and architect in Oracle public cloud infrastructure as service operations, and he will talk about enterprise storage today. I think it will be very interesting.
Yes. Good. Thank you, Dr. Jason. And it's a pleasure to speak. Dr. Gihan Dayas is here. He was my teacher, and I see my colleagues, Chandana and Sanat, you all studied together in this department. But why don't you come forward?
There is a slide.
Yes, that's what I was telling you. And because it is different, you guys have to think differently. Because your competition is not the person next to you. Competition is the global scale. It's the practice and graduate from 3,000 institutions in India and China. So, if there are Indian students, I have gone and spoken in many places. The one role will be occupied first, the other backwards. I was also like in your shoes, just like you, we used to come and sit in the back. It is a backward mindset, and I'm still suffering from that. So you should, I hope you will have the courage to overcome that at some point. So come, there's plenty of room here. Why are you sitting there? Come and sit. Yeah, so we will have a discussion session. I prepared this presentation for Professor Chandana invited me to talk to the IESL professionals as well. So I prepared one presentation, but this will be more in terms of discussion that I use the whiteboard. I hope you have all have taken a computer architecture class right now.
Okay, good. So when I make the statement and say computer storage, what comes to your mind? What pops up into your head? Hard disk, okay. If you were to draw something in thin air, what would it look like? Huh? Yes, cylinder, good. A cylinder. Very good. What else? What is that? Okay, cylinder and a cloud. Okay, very good. Yes. So the thing is, that is correct. I mean, it is the conventional, traditional way of thinking versus cylinder that is connected or inside an enclosure, and there are CPUs and there is memory on the side sitting there. There are cables, ATA or SATA cables that are connecting these things into a bus that talks to the CPUs or memory, and you're doing DMA and all those nice things. That is true. But that mindset, when it goes to the enterprise level storage, is changing. Okay? So in this talk, I will discuss with you, so we will exchange ideas. I will discuss with you what enterprise storage really means, which means someday when you graduate, there are master students, is that right, Professor Sanat? So, master students and final year students, when you graduate, you will go into your respective jobs, and then you will get exposed to these issues. So it is a good thing. My intention is to impart in you a little bit of such things so that it won't hit you like a freight train. Okay, because you will be decision makers. You all are the elite who are graduating from this great school, right? Good. So, we will discuss and learn something. So, my objective would be when you leave today, that there will be a minuscule thing in your heads that this is what storage is about. Okay, enterprise storage, and then I will tell you the later trends of enterprise storage and how it applies to cloud. Okay. So let's say, let me ask a question, different question. Suppose your house is burning. Okay, so you come home in the evening and your house is burning. And so you have the, I mean, of course, you will go and rescue your loved ones. You will rescue your children, your wife, your parents, your mother-in-law, depending on your relationship. Okay? Yes. So you will rescue those, I mean, living things first. Let's assume you did that already. Next, what would you go to? Yes. Very good. Yes, very good. Laptop, very good. Yes. But what are the common attributes there that you, the things in the things that you would rescue? What are the common attributes? Value, yes. Money, you can earn your money.
Things that cannot be replaced.
Exactly, exactly. So when we ask this question, what are the things that cannot be replaced? You mentioned documents that you don't have copies of. What is your pictures? You have digital, in this day and age, there are digital pictures all over the place and it's uploaded to various public sites. But there are certain sets of pictures still in film, right? And those were taken long time ago. Maybe it's your grandmother's, mother's, father's picture, which has the same, only one single copy in the whole wide world, right? So those are it cannot be replaced. So there is the storage. When you think about storage, you have to think in that terms. If my data center is the place where you have your equipment that is doing your data processing for your large enterprise organizations. Data centers, if you go to a Google data center, typically would host, there are things called racks, and a rack would host 42 servers, and there will be thousands and thousands of racks. Okay, so those are the data centers. I mean, of course, in small and medium organizations, the size of the data center will be small. I will talk about those aspects. Okay, so these data centers obviously have storage, because the capacity of storage is increasing ever. So they say that in 2020, the amount of data that is used by the whole population is 50 zettabytes, and 1 zettabyte is 1 trillion gigabytes. Okay, and I think, personally, I think it's going to be more, because for an organization, someday you will have to actually make this call, and you will be very unpopular, where you go to each and every employee and ask them to clean up their mailbox. Or you say, hey, you have maybe you have too much music and movies downloaded and it is costing the organization this amount of money to maintain that storage. I heard such requests maybe about 5-6 years ago. And after that, that request quota is something that people don't do anymore. Of course, there is a limit of what you can do. I mean, if you exceed your storage utilization into hundreds of terabytes, somebody will come and knock on your shoulder and say, hey, what are you doing? But aside from that, nobody is worried about quota. Nobody comes and tells you to clean up your mailbox, because the hours that you spend cleaning up your mailbox as an organization, I'm losing that time. So storage capacity is very cheap, and people are not worried, because they say that there will be 7 billion people by 2020 or 2025, I think, and each person will roughly have close to 1 terabyte of storage on the average. So they say that 2025, 160 zettabytes. In my personal opinion, it's going to be more. But that's a lot. That's a huge amount. So storage is an essential component. However, what is attractive to talk about are about how the CPUs behave, how memories behave. The storage is, some technology which is not too attractive, not too sexy. You just, it's just there. right? It is like your horse that tills your land and the horse that pulls your cart, your luxury cart. The horse that tills your land gives you food and earns your sustenance, whereas the horse that pulls your luxury car is a big show, but you know, you live because of the other horse. It's something like that, okay? So because it is not too attractive, it has not grown to a science as such, but it is indeed something that you have to be extremely careful and think differently. Someday you will be software engineers, you will be system administrators, you will be DevOps engineers, you will be QA engineers, and storage is something that you will every day you will come to use, and you will come to use carefully, as well as you will have to use care in using it. And I will, in this talk, I will tell you why. Okay? So this is about all the data explosion. So the data is never going to decrease, it is ever increasing. So as I said, as a IT specialist, you have to take care of your data. And what does that mean? What does taking care of the data mean? Yes. What are the aspects? Suppose, think about something that you have this big old gold box in your home. What does taking care of that mean?
Prevent people from stealing.
Exactly. People from stealing, and people and say, let's assume that inside this gold box you have some good medicine in there that will save your life one day. You want to make sure that people don't go and insert poison in there, right? The world is a vicious place, unforgiving. Okay, so you have to make sure that you have to make sure that it doesn't fall and crack, and you will lose that resource. Okay, and you have to make sure that it is secure and if it is insured, so that if somebody steals it, that you have some way of financing it, right, and replacing it. So therefore, a data engineer, data, so to speak, the technician. So now don't take offense, I'm saying technician, engineer, those are all political terms. It is not, I'm saying is you're a technologist. I say data technologist in case I offend you elite people. A data technologist should always pay heed to all these aspects. Okay, so you have to protect your data. You have to make sure your data doesn't get into the wrong hands. Losing data is a very bad thing. For example, let's assume today Amazon Web Services, if somebody tweets saying that Amazon Web Services is compromised, within a week I can guarantee you there will be hundreds of customers leaving Amazon Web Services, just like that. So these data breaches are super sensitive things, super sensitive. And not only that, now there are these regulations, regulatory framework that has come into play, and they are saying the laws that have been enacted, like Sarbanes-Oxley, that they say that you lose data and then you detect the data loss, and after certain time you have to mitigate the loss from that data loss, data breach. And beyond that, for every minute that the data is lost, you have to pay several $1,000 compensation per minute to the customer. It's measured in minutes. So it is very expensive, data breaches. And more expensive is the loss of reputation to the company. So if Walmart says, hey, there was a data breach. So recently there was a data breach at Hilton Hotels, and Facebook, and millions of accounts were hacked. And they lost so much face due to that. And not only that, they had to call each and every customer and say, hey, your account was breached and we are going to pay for your credit protection, so that intruders cannot exploit that knowledge that is there. Okay? So the mindset of handling data is different than mindset of handling a network or a CPU or memory, which are, ephemeral things, means you lose those things, you can replace. But data loss, you cannot replace the data. Or if somebody comes and injects something even malicious in there. I remember there was this ransomware recently. There were these crooks who would take a file and then they would encrypt. They will plant something in your computer system and they will encrypt certain random files or some files that they detect using some algorithms. And to decrypt those files, you have to pay into some obscure account. You have to pay using bitcoins and all that, and then it's a big business. And people are not. It is not coming out in a big way because people are worried that their reputation will be tarnished. But it is happening all the time. To get back the files, people do pay. Companies do pay. They will pay it's $150,000. Let's not worry about tracking these people. These people are from some shop in Eastern Europe or somewhere, and they just go pay it off, get the files, and then of course they protect it afterwards. So handling data is super critical, and has to be done with care. Okay. So the storage belongs to, in a very large scheme of things, 3 broad categories: files, blocks, and objects. So in the picture that you had in your mind, what comes into your mind when it says file? What is a file or a file system? What is in, when I say file system, what is your name? Tarindu? Kavindu. When I say Kavindu, how big is your file system? How is your file system, Kavindu? Suddenly the picture comes into your mind, right? What comes into your mind? Yes, a document, yes. An object that holds some amount of data. What else? Yes, folder, correct. A container hierarchy that has, what is the key word? A container hierarchy that has a structure, that defines its placement. Very good. What else? What is that structure called? So there is data and a structure that gives you access to that data. What is that structure called in a file system? What is the technical term that is used? It's called the namespace. So namespace is an overloaded term. In files, the hierarchical directory structure, hierarchical or whatever structure, in most file systems are hierarchical. There are some content addressable systems which has different structures, but the hierarchical structure, we say for simplicity, let's take hierarchical structure, is called the namespace. Okay, and then of course the namespace have pointers to the data that is contained in those objects. So what are the file system namespace objects that you know of? Anybody from this side? I think we'll have a competition. Your turn. What are the file system namespace objects that comes to your mind? He told one, so he has 1 point now. Directories, folders. What else? And obviously files, right? There are files. So there are files and folders. What else? Yes, partitions. Partitions, yes, we will call it. That's okay. That's a good definition. Partitions. Then there are sockets. Then there are device files. Then there are, depending on the file system, then there are named pipes. Okay, so they all are contained in a namespace that it's a polymorphic definition. Each object is defining some object that is either holding data or does some function. Okay, so there are a bunch of different things that a file system namespace can hold, right? So internally, inside a file system, what do you have? How is this namespace maintained? And what is the relationship of the namespace to the blocks? It's a simple picture. Something will come to your mind. What comes to your mind? I think you may have studied this for your computer architecture class. If I write here, can you guys see? Yes. What comes to your mind? Yes, yes, very good. What is that index called? File? Yes, yes, it's an index for sure. Yes. Have you heard of inodes? Yes. Have you heard of data blocks, data indirection, direct and indirect data blocks? Yes. So file system, a namespace has inodes, and these inodes can be a directory or a file or a socket or a named pipe or an IPC, depending on the file system that you used. It's a polymorphic object. And they have enough data that is maintained typically inside kernels, but there are user space file systems as well. So inodes have typically type, what type it is. And then inside that, there are called direct blocks, indirect blocks. Okay? What else do file systems have? Aside from holding files and folders, okay, aside from holding files and folders and other objects in the namespace, what else does a file system do? Yes, very good, very good. So inodes contain access info, popularly called ACLs. What else? And then of course ACLs, access rights there are two types of access rights. There are things called ACLs. If you go into Windows, you will see the ACLs, or if you go to a Linux file system, and if it is supporting POSIX ACLs, you can see ACLs. And of course there are file system permissions as well. The permission bits, right? So I will call them. What else? Yes. Yes. So permissions are simple. It was so when file system started initially, there were a 16-bit field in most inodes that were reserved to maintain the permission, and I was going to show the attributes. So typically in file system technologists parlance, or in their vocabulary, permission is the read, write, execute permissions, and the directory bit for user group and other. So when you do ls-l, you see on your left hand side read, write, execute in a Unix file system, right? So those are called permissions. Now on the other hand, in addition to permissions, there is a rich set of access controls called ACLs. So there are DACLs, which are discretionary access control lists, and there are MACLs, which are mandatory access control lists. Discretionary access control list governs the file system access permissions other than user group other. So for example, I can say Kavindu, so I am the owner. What is your name? Chaluka. So Chaluka is the owner of this file, but I am giving Kavindu read-only permissions. And in the ACL, I can specify that Kavindu has read-only permissions. So there is a Unix command called FACL. I will write some keywords here. Go and look it up. FACL, and then you can specify the ACLs only if the file system supports it. Now what happens is typically many file systems, they reserve some space in the inode itself for the ACLs, but ACLs can grow very large. For example, Windows I think supports today about 1800 ACLs. That's a very large amount. So what is the disadvantage of ACL being big? So note that these inodes, wait, let me come to that story now. So what are the direct blocks? Direct blocks will say, here's a list of disk addresses, and this is where the data is stored that belongs to this inode. Okay? And indirect block will say, now these direct blocks are limited. So indirect block says here are directories of or indexes of other blocks that describe the data addresses. Okay, so this is how the file system maintains the space. Okay. So this is an inode. So this is the fundamental building block of the file system, right? So when I read, suppose I say I call the system called open, okay, to open a file. Immediately, what would the kernel or your standard glibc do when you call open? glibc is the standard C library that implements the system calls, right? When you call open, what would the library do? It will quickly go to the kernel's cache of directories to inodes. Now these inodes are persistent structures. Persistent means it is stored in the disk itself, right? But when the file system, how do you access a file in suppose you have, who has done MKFS? Who has run the command MKFS? Yes, so try it out. It's a fun thing to do. And there is today it's ext4, or you can call xfs and butterfs. There are a bunch of file systems that you can create. Okay. So when you run a command called mkfs, it's a user space command typically. What it does is it goes and formats the file system to hold these inodes and directories. It says, okay, from the whole disk, if this is my disk address space, means let's assume this is the 0th byte and this is the 10 terabyte. It will say, okay, the first 300 megabytes I'm going to give, I mean, there is some area in the header to hold the boot blocks and all that. I'm not going into those details, but it will say the first 300 megabytes I'm going to dedicate for maintaining the metadata of the file system, which is predominantly inodes. But its metadata also includes where the data blocks reside. Okay, so there will typically, these disks will be broken down into several parts. Let's say this is 1 terabyte portion, 1 terabyte portion, 1 terabyte portion, up to 10 of these. And these are called extents. Okay, and typically these are called allocation groups. Allocation groups are large chunk of disk addresses where file system use to manage the file system space. Okay, they are large chunk of disk addresses. Now in allocation groups, file system allocates space in things called extents. So there are two types of file system. Long time ago there was a file system called ext2 where we used to use when we were undergrads here. So ext2 was a block-based file system. But then ext3 evolved, and up to now ext4, many of the file systems are extent-based file systems. What is the difference? So we'll take a simple example. Let's assume hypothetically, I have a file system with 20 sectors. Okay, file system used typically, let's take a simple disk. It's a disk, has 20 blocks, let's say 20 blocks, and each block is 1K size. So the whole disk is 20K, okay? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 8, 9, 10. Okay, I have 20. So each of these is a disk block. Okay, so you can read and write. That is the smallest block in the disk that the file system will let you read or write. Okay, so now you want to find out, okay, how am I representing these disk blocks in your in any of my data structures. So for a simple example, assume you have 1 million rupees. 1 million rupees in your wallet today. Okay, don't raise your hand, you will be at risk. Okay, you have 1 million rupees in your wallet today. Okay, and your 1 million rupees are in different denominations. You have 5,000 rupee notes, 100 rupee notes, 50 rupee notes, 5 rupee notes, or in all different types. Okay, and they are all jumbled up. Okay, so now somebody asks you, give me 353 rupees from this. What do? You put your pocket and get a big bunch of notes. Oh, all 5,000s. Put it back. Other pocket get, oh, okay, 100 rupee note, but all are 1,000 rupee notes. Okay, so there are different contingents. So you have two choices to make this search easy. One choice is to keep all that 1 million rupees in a single denomination, 1 rupee coins, right? So you will have two gunny bags on this shoulder one and the other shoulder one, right? With 1 million rupees, somebody asks 353, you will put your hand there, take somewhere, count 353 rupees and give, right? So what is the, and or you can have maybe a small bag of 5,000 rupee notes, right? But if somebody asks 353 rupees, how are you going to give it? Yes, yes. What would you do? Do you have a choice? You have to give 353 rupees. Do you have a choice? You don't have a choice. What would you do? No, you can't change. You have to give something. He is coming and asking you money and you are trying to change. He doesn't have money. Yes. Say, give 5,000 here, take the 5,000, please don't cry, go away, take the 5,000 and go away. I mean, he's very happy, right? Right. See, that is the thing. So what did you lose? Your data got fragmented because of that. Because instead of giving a 353 rupees to him, now you gave a 5,000 rupee note and you lost 4,600 odd rupees to him. On the other hand, you had this big two gunny bags with 1 rupee coins in your sides, where you can't go to the bus hall from here because you have to now carry this thing and you need maybe a car or I don't know, wheelbarrow to take that money, right? What does that mean? What does that mean to a disk maintaining this metadata? Means if you maintain the data in blocks, your directory sizes will be so big because you have to maintain the address, you have to maintain a mapping of ownership of each and every block to some inode, and those directories will be so big that it will be terribly inefficient to maintain, space-wise as well as lookup-wise, right? So these 300 megabytes will be maybe 2 terabytes, which means you will be wasting 20% of your space for maintaining metadata. Yes, exactly, right? Wheelbarrow. On the other hand, you also have the choice of increasing, having larger data blocks. Maybe you can have 10 terabytes, I will say 1 terabyte data blocks. I have only 20 KB, I will have maybe 10 kb, two 10 kb blocks, but you have less choices of allocation and you will fragment the data and you will waste space. So therefore, what do people do? What is the alternative? Think about the money example. Now you have no choice but to maintain different denominations of coins, because people will ask 353, somebody will ask 5055 and some various weird numbers because they are crazy. What is your choice? It's a practical real life problem. What would you do? You keep the money, you won't give it, right? That's okay. Besides that, you have 1 million rupees and you have to give, say you have to give. There is a rule or law that says you have to give. What would you do? Yes, yes, yes. Think. Let's see, it's a practical problem. Anybody from the back? Don't worry about storage. It's not a storage problem. It's a practical, simple problem in real life. I'm sure all of you will own more than 1 million rupees and will carry that money in your life. Will you take 5,000 rupee notes and 1,000 rupee notes and 1 rupee coin and put in a single bag and just shuffle it around like this and say, okay, I'm going to pick whatever I have randomly and give? No, right? So what you will do is, if you're sensible, of course, is that you will have a bunch of 5,000 rupee notes stashed up somewhere else, a bunch of 1,000 rupee notes stashed up in different denominations. You will have it sorted, and whenever as necessary, you will pull from here and pull from there, pull from here, and then you say, yes, 353 rupees, please go away, don't cry. Right? And what did you do there? What is the difference? You maintain these data blocks on the base of their availability. You maintain those data blocks in bunches. And what happened because of that? Who spoke? Oh, yes, sorry. Yes. Good idea. Good idea. We'll come back to that. Okay. But what happened was you reduced your directory structures now. Instead of having 2 bags full of things you have to carry on a wheelbarrow, now you can carry it on your briefcase. Money of different denominations. Just like that, the file system space 2 is represented in extents instead of blocks. In ext2, it was a block-based file system, terribly inefficient, search was bad, fragmentation was fantastic, no fragmentation, because you could allocate from each and every block, right? However, metadata space was huge and performance was very bad, right? So what now people do is, they maintain and say, it's a data structure that says start block is here's the data structure of an extent. You have a start block and the length. Actually, instead of size, I will say length. It's more explanatory. Length. And the whole disk is an array of extents. So you will have extents. If I were to represent that, I will have extents of 1 GB extents. I will have 10 1 GB extents. Then I will have 20 100 KB extents. And your file system maintains this information in the file system metadata. Okay, and based on the demands, when you say, okay, here's an interesting thing. If you do it today, you go and try this out today. Okay, write a simple C program. Okay, open a file in write mode. You can create that file. Open a write in write and create mode. Okay, and then write a 1 kilobyte block. Just say write and call the system call, write a 1 kilobyte block at the start of the file, and let's assume your file system is 100 gigabytes. Then seek, okay, call you have the file descriptor, call lseek and call it an lseek to 13 terabytes on a 1 gigabyte file system, and write another 100 kilobyte block there at the end, and do ls-l and see what the file size is. Try it out, okay? I will tell you how it works. So, when you do that, the file system allocates space for you. Now, I hope you understood the catch in the statement I just made. You have only 100 gigabyte disk space, but you created a 13 terabyte file in there. And when you do ls-l, you will see 13 terabytes. Your file system will show that you have 13 terabytes there, because the namespace shows the size of the file object. So, inode also carries the size in blocks. Okay, inode also carries the size in blocks, and there is another inode of called what? Okay, I will come to that, that is okay, we will leave that for the moment. So, inode carries the size in blocks, right. The namespace of the file system says this file is 13 terabytes, but the true number of blocks that you use in your file system is maybe 200 kilobytes or whatever the amount that you wrote. So, the space allocator of the file system went through these directories of extents and allocated only the space that you wrote. It did not try to allocate 13 terabytes. It only allocates the amount you used. But the namespace of the file system shows, because you wanted a 13 terabyte file, you have a 13 terabyte file. But if you try to write from the beginning of the file and now try to fill that file 13 terabytes, the moment it hits the 100 gigabyte mark, it will say, sorry sir, you do not have any more space to do it. Okay. So, therefore, now what happens? You represented this data structure, which is called an extent, and you reduced the directory size because you represented the file system in extents. Now, we said before, I made a statement that if you maintain the disks, if you maintain the allocation sizes in large data chunks, you will face fragmentation. You gave the 5,000 rupees to somebody who wanted 353 rupees. He is a very happy person, but you gave that 5,000 rupees. Now, this gentleman rightfully asked, he is a sharp person, he is very good. Will there be fragmentation? Can there be fragmentation here? Yes, yes. So, let's take a simple thing, simple example, okay. Let's assume I have 10 data blocks, 1, 2, 3, 4, 5, 6, 7, 8, 10, okay. And let's assume I have, somebody asked me for 5 data chunks, okay. So, I allocated the extent, this extent to somebody, okay. Then somebody asked me for 3, okay. So, I allocated from here, here and here, right. Now I have how many extents here? How many extents in my file system data structure here? Yes, yes. Who can tell me? We have a start block and the length, and I use that start block and the length to allocate space. How many extents are here? From this side, somebody from this side? So, I have one extent here which I have already allocated to the check mark. I have one extent here which of size 1 block size. I have another extent here. Now, I have allocated this to the cross mark and I have another extent here, right. So, as long as I can allocate one block sizes, there will be no fragmentation. However, if somebody asks me for 2 blocks now, right, I have to assign him one extent here and another extent there, right. So, my metadata size now increased, right. So, let us assume at some point this person says, hey, I don't want 3 blocks. So, he says I don't want this block. Now, he is free. So, now this became an extent, he is free, he is free. So, this became an extent, this one became a free extent, and let us assume this also became free. So, now this became an extent of 2 that is free and this became an extent of 1 that is free. Now, how many extents are there? Yes. So, as you can see, when the blocks are allocated and deallocated, the sizes of the extents become small and small and smaller, and the directory sizes become larger and larger. So, file systems technologists, I am refraining from using the word technician, file system technologists use different techniques, different algorithms, and I want you to look it up, study those are very interesting things of how to improve the extent sizes. That is a huge file system developers problem, and people have solved it to reduce the map sizes, reduce the extent size. Eventually, if you go like this, because you can't dictate as a file system technologist, you can't dictate how the customer will give up data blocks and access data blocks. Because customer, if he wants, he will say I am going to delete this block here, that block there, everywhere. So, eventually over a period of time, your fragmentation, not the fragmentation, your map sizes, directory sizes of space will increase all the way, which is bad, which means that you will slowly lose performance in your file systems, because to access each file. And so, how do you access a file? Simply let us assume if you want to write a C program or any programming language, Python program, whatever programming language that you want to use to access a file. Let us say you want to access the 100th byte offset of a file. How would you do that in a program? Anybody? Actually, anybody? Just give me 3 lines. You want to access the 100th line of a file. What would you do? Obviously, you have to open the file. Very nice. You have to open the file. You get, when you open a file, what do you get back? What is a file descriptor? So, you have a file descriptor, and then what do? You have to access the 100th byte. You have a file descriptor. What is the system call you call to move the file pointer to the 100th byte? Seek, lseek, you call that. You move your file pointer and then you read from there, right. So, when you do that, remember when you do lseek to the 100th byte, somebody has to look up the inode, somebody has to look up the direct and indirect blocks that is maintained in the inode and move and tell the operating system this at this pointer in the file, at this offset of the file is in this data block on the disk, right.
On the disk.
Yes, on the disk.
Still not
Yes.
come to the memory.
No, it does not. And then you obviously you read the contents, and then of course it goes through page caches and all those nice things, and then it comes to memory and then you access it, right. Fair deal? So, this is space allocation, and so file systems are maintained in extents. So, most of the contemporary file systems are maintained in extents. Okay, so this is the importance. This is I hope you got a feel about file systems and how to develop the technologies. There's fun stuff. I mean, of course, I just scratched the surface. There's lots of different stuff that is going on with file systems. Okay. So, then I talked about this 13 terabyte thing, right. In a 1 gigabyte file system, you can create 13 terabyte file, and how that is done is the file system only allocates blocks on demand. Now, given a file descriptor, suppose you open the file, open something file name, you open the file. How do you know the size of that file? What is the system call you use to learn the size of that file? Now, I mean, I am talking in Unix, Linux terms. I don't know anybody sensible uses Windows. I have no idea. But in Linux, Unix environments, what is the system call you use to find the size of the file? Stat, fstat, look it up, try it out. Okay, when you call that, that thing looks at the inodes of the file system and will give you all the information about that file. What is the size of the file in bytes, what is the size of the file in blocks, and also what was the last access time of the file, what was the creation time of the file, and what are the current attributes, and what are the current permissions. So, this guy also has all those data. Okay. So when you do, so what happened was when you do ls-l. So, for example, if you want to find out what are the system calls that are being used when a particular command is run, when ls-l or ps, when you call ps, what is the output when you call ps in a Unix or Linux system? What would you get? Yes, you will get the information about the process tree. What would you use? What is the command to, if you want to investigate? What is happening inside the system? What would you use? What is the command you use? You use a trace. You trace, investigate, find out to yourself. That's an invaluable tool. If you want to find out, hey, what's happening forever, one time you are curious. I am doing ls-l every day, and you know what is happening inside. Usually elite people will always ask those questions without using ls-l every day. They will always ask what's happening inside. Okay? So, use trace and it will give you a listing of what is happening, what are the system calls that are being called, and what are the things that are being reported. or returned from the operating system, and that is a valuable tool. So, when you call S trace on ls-l, you will see that it calls stat on each and every file system object there and get the stat information and get all the information that are stored, most of the information that are stored in the inode. Now, what that will also give are two data points. It will give you the size that is recorded in the file system namespace as well as the true number of blocks that is occupied by the file. st underscore size in the data structure and st underscore blocks in the data structure will give you two different. So, st size will be 13 terabytes and st blocks will be 1 KB blocks. Okay, try it out, write a simple C program or Python program and you can find out what is happening there. So, those are called sparse files. Then file systems have, so file systems, so in enterprise storage world, file systems use things called data services. Okay, if people will say, okay, give me a file system, say I'm selling you a file system, I'm saying, hey Kavindu, please buy my file system and give me $100,000. I'm giving you a file system, and then what would you ask? All right, file system, very good. I can create my own file system for free if I want. Right? Why would I give you $100,000? And then I will say, hey, you can go and get Btrfs, ext4, this thing, that thing, 100,000 different file systems. But I will give you additional data services with my file system. And what are these data services? These data services are disaster recovery, means I will have built-in constructs in my file system for for disaster recovery. What is a disaster recovery? Yes. Yes. So, the place where I am keeping all my file system data is gone. Is gone. Somebody set fire to it, or I don't know, various things can happen, right? So, or somebody just stepped on it wrong and the whole rack fell down on the side and crashed all my disks. In that case, I have to have a way of recovering that information, that data at some point. So, I have to have a disaster recovery plan, and I have built-in disaster recovery hooks, which is not available in normal file systems. So, that is one data service. What else? The dreaded quota, means everybody can't use hundreds of gigabytes of in a file system where I am sharing the file system with many people. There is a quota service. What else? There is thin provisioning or on-demand provisioning. What is on-demand and thin provisioning? These are things people will absolutely talk to you when you all are storage technologies to sell things. Yes, you know, when you are marrying, when you are on your wedding day, either your bride or the groom will well dressed. You see, that is what the sales people do. Thin provisioning. What is thin provisioning? Yes, somebody knows about it. Yes. What is thin provisioning? Thin provisioning, or some people call it on-demand provisioning, means that the files you can today buy from me. So, suppose I am selling you a 100 terabyte file system, but you tell me, hey, I don't have to pay you 100 terabyte worth of money today, because my 100 terabyte estimate is for the next 5 years. Why would I pay 100 terabytes today? Today, for the next 8 months, my storage demand is 10 terabytes. So, you give me the file system for 100 terabytes, but with disks, that are hardware media that is involved or installed there only for 10 terabytes, and I will only pay you that. Then after a year come back, I will sign a support contract with you. After a year come back, then give me 20 more terabytes. Then next year come back, give me more 30 more terabytes, etc., etc. So that is called on-demand provisioning, and the file system has constructs to do that. So thin provisioning or on-demand provisioning. Then rich yes, so this is the conventional file system, sir. It is the file system that is used. I will come to the cloud part shortly. Yes, somewhere. It is a file system that I am trying to come in and I will install on your site, on your premises. Okay. So the thin provisioning means you are saving costs upfront, right? You don't have to dole out hundreds and thousands of rupees for storage. You can, as you go, you can pay for the storage that's been used, right? So that is thin provisioning. Then these rich ACLs, for example, not for all file systems support ACLs. You can say, hey, my file system supports POSIX ACLs, or my file system supports Windows DACLs, and it can.
Provisioning would be from the client's perspective, right? So I
Yes.
will pay, but you have to pay for the whole thing if you are coming and installing on premise.
No, I don't. I have my file system structure such that I can come and just plug in. So what happens is, I will suppose you order 100 terabyte file system, and I will bring you a storage enclosure, and in that there are slots, disk slots, 10 disk slots with 10 terabyte disk slots. Initially only 2 disks will be there populated. So after a while you will call and say, not you actually, I will be monitoring, and these enterprise storage vendors monitor the storage usage, and when the storage usage exceeds 60%, the rule of the thumb is, when the storage usage exceeds 60%, it's time to take action, and when it exceeds 80%, it is an alarm bell, and when it exceeds 90%, it is time for you to stop your service loss, means it is time for you to bring down your file system, and if it goes to 100%, you will corrupt data for very large file systems. So those are the rules of the thumb. So when it 60%, somebody will be monitoring, and you will be giving me a call, Chandana, and then I will be bringing you maybe another 2 disks, and you don't have to stop anything. You just insert the disk will get hot plugged by the operating system. It will detect it, it will detect the space that is allocated. Maybe I have some metadata in the disk that will get auto incorporated into my file system, and then you will never know that I hot plugged the disks. That is the upfront agreement. Okay, so that is thin provisioning or on-demand provisioning. Then there are these, as I mentioned, these ACLs, disaster recovery, and then bunch of such services. And those services are the things that truly people use to differentiate their products. So you have the choice of going to a company like NetApp or EMC Dell or HP and buying a server or bunch of servers that has file systems built into your organization and pay a gazillion amount of money, but have reliable service, okay, forever. Or you have the choice, suppose such file systems, on the rule of the thumb average, it is about $250,000 to $1 million, such file systems. On the other hand, you can construct with maybe better performance, similar performance with similar features, you can construct a file system for $20,000 with 1/10 of the cost, but you run the risk of operating that, which means your CEO calls and says, hey, where is my data? My data with the customer employee information is corrupted. Now what are you going to do about that? I tried to save $230,000 and now I have a data loss situation. And now my employees will come and sue me for $500,000. So, it is a balance, of course, there is a balance, and as a storage technologist you will have to make that call, and you have to, so to make that call you have to be aware of this technology, and I encourage you, it is easy to be dazzled by the marketing terms and put this term, that term, fancy terms here and there, but there is always technology that goes inside. Understand what it means and make wise decisions, which means you are not paying unnecessarily for buzzwords. Okay, so use these things, S-trace, F-stat, try those out, understand what is going inside in a file system, and make the right choices for your organization. All right. So, now let us assume now here comes the cloud. What is happening in the cloud with file systems? So, cloud file system services. So let's take a typical use case. Okay. So, now your organization for some interesting reason has decided, hey, enough of these things that I want to maintain my data center, I do not want to maintain any more data centers. I just want to put all my workflows and my procedures in the cloud. So, therefore, they will come and say, what is your name? Dulanjan? Okay. They will come and tell you, hey, find me a solution. Go somewhere, find me a cloud based file system solution, right. So, you would go to Amazon, you would go to Google, you would go to Microsoft Azure, you would go to Oracle, then you would go to IBM, and you would go to Rackspace, and you would go to CenturyLink, a bunch of people who are giving these services, right, and maybe there are people here as well, I do not know. So, you will go to such place and you will try to evaluate, okay, what are the services I am getting from the cloud. Now, when you go to a cloud file system, all these nice things are taken away from you. You do not have to worry about it. You are getting a namespace. It is already disaster recovery. All those data services that the customers provide, the vendors provide you are already provided for you. Okay, and not only that, you are paying on demand. Means when you use X number of blocks are allocated. Of course, behind the scenes your cloud vendor is doing all of these things, but he has taken care of that for you, and he will give you what? What will he give you different? He will give you something called a mount point. He will tell you, hey, you want a file system, here is an instance in my cloud environment. Instance is a server, a virtual server that is running somewhere, which has a public IP which you can access via your VPN. It is a secure channel. Go ahead, here is the file system, please mount it. The file system is installed here, and you do not have to do MKFS, you do not have to do FSCK. You do not have to do FSCK, you do not have to do MKFS, all your cloud vendor has taken care of for that. You do not have to worry about thin provisioning, this thing, that thing, it is automatically thin provisioned. And not only that, your cloud vendor will also ensure that your data is replicated. So, which means that if one place your disks are crashed, the cloud vendor has already replicated your data in another place. Right. So, that headache is taken care of for you, means there is a very little chance of you losing data, but there is a chance of you losing data. I will tell you when that happens, okay. But the little chance of you losing data in the file system is given by the nines. Now, this is the nines is another marketing term. Amazon will say, hey, in Amazon S3, which is Amazon's object store, my durability or the availability is 11 nines, means 99.9 da 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 11 times percentage is available, and they stick to it. So, which means that they replicate each data block that x number of times. There is a formula that does this x number of times to make sure that there is no data corruption, and they have quorum based. Quorum based means, so let us assume I have 10 data blocks. I have replicated the same data block 10 times. So, I get answer A, B, A, C when I read this data block, right. I have A and C. Now, this answer C is coming from a corrupted data block, and it happens all the time. It happens now. These, note that these are server farms which have millions of disks. So, getting corrupted data is a normal thing, and all cloud service providers accept that the data blocks will get corrupted. But you get block A and C, and then what happens is the quorum based algorithm will see, hey, this has the signature A, this has the signature A, this has the signature A, but this signature C. I have the majority, I got A, therefore this data will be A, and it returns to the customer, right. So, that is a quorum based, means majority rule. So, what happens is these can go wrong, and there have been instances where data has been corrupted, which means that you get B here and D here. Now, there is no clear quorum there, but for that to happen, 11 copies of data on different servers in different availability domains have to get corrupted. Means 11 copies of data on different servers, different disks, on different data centers. The replication happens across geographical locations for this to happen. So, they have internal ways of enhancing the performance of this type of things, but that replication is making sure that your data is not corrupted, right. So, is going to a cloud based file system, is it a rosy picture? Is it the best thing that can happen in the world to you? Why is not everybody not going to the cloud there, if that is the best thing? Looks like everybody, this thing is taken care of for you, right? Everything. Okay. What about security policies? Yes. Access to their data. Okay. So, they say, hey, you are telling me it's good, cloud is all good, but I want to keep my data. And what about it? Why is that data security, why is data governance an issue? What are the things that can happen? Why is data governance an issue? Why are people scared of that? No, see what happens is if you relinquish all your data to a third party, that third party has, so jury is out. I mean, people will deny that all they want, but that third party has less motivation to protect that data from various government related interference than the person who owns that data. So, for example, let us assume I am living in a country where there are lots of let us say money laundering. Okay, there are people who is moving money underhand, not paying taxes, and nobody knows how the money is moved. Then I am the president of this country and I want to know, hey, who is taking my money? How come my people are so rich, but I am getting so little taxes? So, what he goes to the company and saying, all these banks or whoever, saying, hey, give me all your records. I want to see all your records and all your transactions. But banks will say, hey, you can't ask my records. There are legal protections that have been given to me. So, go to hell, I am not going to give you. So then you say, okay, let's go to a lawsuit, and the lawsuit goes for 3-4 years, then they bribe the officials here and there, and then ultimately the issue will go away, banks will always win, right? Because they are very, very conscious about that. Now on the other hand, bank has given that information to, let's say, some company who is hosting their data, then the government will say, bank, okay, good, I don't care about you, I will go to that hosting provider and say, hey, I want all the data of this bank in the file system. And that guy will say, bank, hey, what are you saying? Should we give? So bank says, no, don't give, it's my data, please don't give. So I will say, okay, I won't give. And the government will come and say, hey, if you don't give, I am going to put a lawsuit on you that you will not be able to host any more data. And then I know I have to worry about my food and my things. You say, okay, take. That is what's happening. So this is not explicitly stated anywhere, but that happens all the time. If I am the hosting provider, I have less motivation to protect your data. So therefore, people are paranoid about relinquishing control. So that happens all the time. And then there are these other things. So there is a concept, there is a data service called deduplication, where the file system itself, it will detect the blocks that have the same contents and it will compress it. Okay? Of course, if there is a copy of, if I have two blocks which have the same content A and A here, and this address is X and this address is Y, okay? Instead of maintaining an additional wasting an additional block in the inode, I can say this content is X and here's a pointer. In the pointer to Y, I can say please look up X, right? So there is deduplication. So now recently there was this this article where deduplication in the file uploads. So there is a thing called, you should look this up, enterprise file sync and share, like Dropbox or Box or Ignite, OneDrive. That is an enterprise file sync and share service. So what they have, one of those vendors who went IPO recently, they said, okay, fine, you can upload and we will deduplicate on our side. Means suppose you upload the file that contains X, okay, and then you upload the second file that contains X. If this took 100 seconds to upload, this will take 1 millisecond to upload, because inside the file system the vendor will detect I already have the file X and I will deduplicate. You don't have to tell me again, because in your file system I will make a deduplicated pointer. So by reference it maintains these contents. Okay? So what happened? Now you know these music service providers, right? Music studios. We pirate music all the time, right? Yes? Do you? You download MP3s from this person, that person, everywhere. All illegal MP3s. I have never known, I mean, I can deny that all I want, but everybody does it. Okay? So, it's recorded now, it's an admission, I hope nobody will come here. Okay? So now, so I'm denying that explicitly here. So what happened was, now what the music studios got to know this, and so this company was hosting files of millions and millions of people all around the world. And what they did was, the fresh music that they released, they uploaded into this this file system service. And what happened? A 3 gigabyte file was uploaded in milliseconds over the internet, which was impossible, because they deduplicated at the file, the vendor, at the host. And what happened? Then the music studio says, hey, you have a copy. How did you get a copy? Because I have not even released my album yet. I have not released Harry Potter. How did you get the copy of Harry Potter there? And then they sued this vendor to get the people's the names of the people who had uploaded. So there was a huge lawsuit, well-known lawsuit. Look it up. But somehow it went hush-hush. I think they bribed 100 different people, and somehow it ended up not an issue. But that thing totally happened, and it stalled the operations of this company for a while, because government got involved, and then they stopped deduplicating files across ownership domains, right? So therefore, data governance is an issue. And also, what is more important? Not, I wouldn't say more important. What else is important? The cloud services are subscription based. What does that mean?
Metering.
Yes, metering. What does that mean? Subscription based. It is money. If you don't use the cloud file service judiciously, all the data you can upload, all you want, but everything you download, you are paying for the bandwidth per month, per hour, per minute. And all the disk space you are using, you pay for the month, per minute. All the processing power you pay, it's a subscription based service. Now, if you use it judiciously, and if you do data transfers within the cloud domain, it's all free. But it is very difficult to move data in and out. And if your applications or workflows are such that you need some data locally and you need some data there, it becomes a fairly costly affair. And you are paying based on time and usage, instead of in the other case, you are making a fixed investment to buy capital expenditure. In terms of capital expenditure, you are paying a fixed amount to buy the servers, and then you maintain. So the jury is out. I am not saying one is better than the other, but it is not very clear that there is a cost advantage going to cloud. Sometimes it depends on your mileage. So as a storage technologist, you have to pay attention to that. Otherwise, you will ruin your companies you are working for, and send them to the cleaners. Okay, so that is something. So there are advantages and disadvantages. Everything has to be taken with a pinch of salt. What people say, the good things, bad things, and you have to make the best decision for the organization that you are working for, and for that you have to get in deep down into the bowels of technology. You go investigate, look up things, find out. Don't settle for less. Don't compromise your curiosity. Do things, because the software engineer's role in the industry is changing. It is no longer a siloed role. People don't hire you for a C++ programmer or C# programmer or Java programmer. People hire you for your ability to do work. It is called fungibility. They want more fungible people. Look up the term and see whether you can relate it to yourself. Okay? So what is happening is there are some engineers from these cloud hosting companies are hired as DevOps engineers, which is a very popular and a very lucrative, very lucrative profession to be. DevOps engineers not only do software development, they also manage operations, they do monitoring, metering, and also they build computers, they build data centers. Okay, so they are DevOps engineers. Then there are engineers in test. Means now, some time back, there were people who were formerly called QA engineers, who the software engineer will do something, won't unit test, then commit the code, and then something goes wrong. Hey, QA guy, it's your fault. That model is going to go away. If you are writing code, it is your responsibility to test. There is nobody in your organization who will do your dirty work. You have to do the sufficient testing, and then you have to automate those tests and then submit it into a CI/CD pipeline, continuous integration, continuous delivery pipeline. So therefore, the siloed professions are changing. It's changing heavily. You go out there, you will be pleasantly or unpleasantly surprised. The things that you learn about Booch and various software engineering models in your software engineering class are good. They are very good foundations, but the roles of software engineers are changing. Then of course there are developers, and then there are people who are called developers but doing more development plus operations. So, so keep an open mind, see what is happening in the world, go into a Indeed or Monster or whatever recruitment sites in these places and see what the job requirements are. Go look at what are the open source tools that DevOps use, like Kubernetes or Ansible or Elk tools that are being used for DevOps. Those will become a essential prerequisite to find an employment in the cloud era. Okay, having said that, I think my time is up. I wish I had more time, but I wish you all the best. I hope you will take something, actually not from this talk, not as a comprehensive lecture, but something that could have piqued your curiosity, and look this up, do things, write some code, find out what is happening, and be more equipped when you graduate and become elite people from Morato University. Any questions that I can help you with? Ask me anything which I talked or you want to. Yes. No questions, so you're too hungry, it's lunchtime, right? Yes, okay. All right, thank you.
So one thing maybe you want to know whether you do any recruitment.
Yes, so so currently for my team at Oracle, we are hiring only from not only, we are hiring people who have done master's degrees. So I encourage you to look beyond your bachelor's and graduating from there, but the personal circumstances of people may be different. That does not mean that we are exclusively looking for people who have done master's degrees, but that is not an essential prerequisite, but it is a prerequisite. Okay, so other than that, if you have